Hello everyone, welcome to Infocular. आज हम पढ़ेंगे ऑक्सीजन डिसोसिएशन कर्व कॉन्सेप्ट फ्रॉम फिजियोलॉजी. बहुत ही क्यूट कॉन्सेप्ट है, बहुत फ्रीक्वेंटली एग्जाम्स में आती है. लेट्स होप you'll be able to master it by the end of this video. Let's get started. What is oxygen dissociation curve? क्या है ऑक्सीजन को डिसोसिएट करने वाली कर्व क्या है? It is a sigmoid shaped curve. Sigmoid shape मतलब S shaped curve है. कहाँ पे S बन रही है ये? Now there is a y axis and there is an x axis. इस y axis पे there is saturation of O2 that is depicted और x axis पे partial pressure of oxygen. इन दोनों की जो रिलेशनशिप है इसको डिपिक्ट करती है ऑक्सीजन डिसोसिएशन कर्व. It is also reflective of the hemoglobin affinity for oxygen at any point of time and at any place in the body. वहां की जो लोकल हेमोग्लोबिन है उसकी ऑक्सीजन एफिनिटी कितनी है is reflected in the oxygen dissociation curve, and this is an S-shaped or sigmoid shaped curve. अब जानेंगे इसकी थोड़ी डिटेल्स. What happens when deoxygenated blood from heart enters the lung? When it goes to the lung, there is obvious gaseous exchange. CO2 enters and diffuses into alveoli, whereas O2 is absorbed back into the blood. And फिर ये oxygenation cause करती है. And this blood will head straight to the heart where it is pumped and released for transferring into tissues. Now, at all these levels, whether it is at the level of capillaries in the lungs or whether an oxygenated blood which is still on way to go to the tissues or at the level of tissues, हर जगह पे the demand or the oxygen affinity changes. Hemoglobin is not uniform. Its tendency to bind with an oxygen is not uniform. And this depends on the conformational structure of hemoglobin, जिसमें 4 binding sites होती हैं. So these binding sites in a hemoglobin structure have 4 oxygen binding sites. Now, what is positive cooperativity? It is a feature seen in most enzymes or receptors that have multiple binding sites. इसमें क्या है? An oxygen molecule with some difficulty comes and attaches to a ferrous ion. Hemoglobin की structure में पहला आके वो attach होता है. After this, once this takes place, there is conformational change in the structure that increases the affinity of oxygen, and वो quickly oxygen number 2, 3 and 4 आके bind कर जाती है at all 4 sites. This is positive cooperativity. There have to be few factors who affect this graph. इस पूरी प्रोसेस की हेमोग्लोबिन एफिनिटी को अफेक्ट करने वाले कुछ फैक्टर्स होने चाहिए. Now, one such factor is H+. The presence of H+ when greater brings about stable hemoglobin. So it brings about stable hemoglobin. Similarly, when there is formation of carbaminohemoglobin, this also, that is increased partial pressure of carbon dioxide, will also stabilize the hemoglobin. Next is increased concentration of 2,3-DPG. जब 2,3-DPG बढ़ती है तो we've all known that the oxygen released to the tissue is favored and hence it reduces the affinity of hemoglobin to oxygen. So the binding reduces. Hemoglobin binding with carbon monoxide is, we have all learned, बचपन में भी पढ़ा है, 200 to 250 times more readily react कर जाती है oxygen with carbon monoxide. Even that will be a factor that will affect the curve. Any residual heme with oxygenated ferrous ion is unable to unload its bound oxygen into tissues, और इससे impair हो जाती है hemoglobin की cooperativity, thereby increasing its affinity with oxygen. Now, all of these, that is pH or carbon dioxide, 2,3-DPG, all of these conditions will be bringing about either a right shift to the curve or the left shift. मतलब graph either slightly right को जाएगी or left को जाएगी. Now let us give definitive conditions on which there is these particular shifts. Let us comprehend this graph. We can see that the sigmoid shaped curve towards the right hand side shows increased partial pressure of oxygen and increased saturation of oxygen. Hence it is depictive of lungs due to extensive gaseous exchange, whereas on the left side of the graph we can see that there is decreased partial pressure of oxygen and decreased saturation of oxygen, mostly seen in exercising tissues or tissues where the oxygen consumption is high or utilization is high. Now, what are the conditions that cause the right shift? Conditions that cause the right shift and conditions that cause the left shift. The right shift is caused by increasing of most parameters. So increased H plus, increased CO2, increased temperature, increased 2,3 DPG, conditions such as hypoxia, exercising, or high altitude, enzymes such as growth hormone, thyroid hormone, androgens, and anemia such as HBS, that is sickle cell anemia. All of these will favor increased binding of oxygen to the hemoglobin and hence will show a right shift. Now, what are the conditions that show a left shift? The left shift is seen in decreased hydrogen ions, that is increased pH. Do not put pH in your criteria, otherwise this will cause confusion. So I am avoiding it. We'll stick to hydrogen ions. Decreased hydrogen ions, decreased carbon dioxide, that is hypocarbia, decreased temperature, that is hypothermia, decreased 2,3 DPG. Then other fetal hemoglobin, which is also showing decreased 2,3 DPG. Then there is methemoglobinemia or hemoglobins such as Rejan, or cheapskate is another one, Chisa PK, if I've pronounced it right. Other forms of stored blood. So these causes will cause a left shift in the hemoglobin curve. We have already covered the parameters of pH, carbon dioxide, 2,3 DPG, and carbon monoxide. Carbon monoxide in such a way where carbon monoxide has usually 200 to 250 times the affinity to bind with oxygen. So obviously, to bind with hemoglobin, I'm sorry. So obviously, oxygen affinity reduces. Now, what is positive cooperativity? I've already mentioned that many enzymes or receptors having multiple binding sites tend to have difficulty in the binding of the first molecule, but later this whole binding process enhances due to conformational change. Fetal hemoglobin में एक important point बतानी थी आपको, that this shows decreased 2,3 DPG, and therefore in spite of everything, fetal hemoglobin show very high oxygen binding capacity. ये भी एक बार question आया था, and 2,3 DPG पे भी आता है. 2,3 DPG is reduced in all those conditions. 2,3 DPG will be increased in all those conditions such as high altitude, जहाँ पे oxygen binding ज़्यादा चाहिए rather than release of oxygen into tissues, or exercising, or hypoxia, tissue hypoxia in general. Now let us test ourselves whether we've understood enough from the video. What shifts the oxygen dissociation curve to the right? And I'm hoping that you'll be able to answer is fetal hemoglobin. Does it shift it to the right or the left? We all know that fetal hemoglobin, with increased oxygen affinity, shifts it to the left. Sickle cell anemia shifts to the right. Hypothermia again is a decreased parameter, so left. High altitude, that is increased parameter, to the right, also due to increased 2,3 DPG. Now, so the correct answer comes up to be 2 and 4, that is the option D, which is the right answer. Hope you've comprehended well. Hope you've been able to master this concept and you'll not make a mistake in the exams. Keep reading, be motivated. Happy reading.